Oh, hello there. So this is question 4. You're told to find the linear differential operator that annihilates the following functions. So I'm going to start with the first one, which is a. So a says we're given the function as x cubed into 1 minus 5x. This is the function we want to find the annihilator operator of. So the first step you want to do is you expand the function. Expanding, you have x cubed minus 5x to the power 4. Now the highest degree of this polynomial function is 4. So since this is the highest degree, it implies that the operator is going to be d to the power 4 plus 1, and which is d to the power 5. You might want to confirm that. So let's confirm. So we have d to the power 5. Let it operate on x cubed minus 5x to the power 4. So this is going to be d to the power 5 of x cubed minus 5d power 5, the fifth derivative anyway of x4. Now this gives us 0 minus 5 times 0, and which gives us 0. So that shows that that works. And for the next one, we're given x plus 3x e to the power 6x. Now this is quite different from the first one. It's different in the sense that we have two different kinds of term there. So the first term contains only x, while the other term is of this form. This is just a polynomial, another polynomial, while this is just 3x, a multiple of this by an algebraic term x. So how are we going to do something like this? So the first thing is, in trying to do, whenever you come across cases like this, you find the annihilator of each family. When you've gotten the annihilator, then multiply the two annihilators together. Whatever you get as your product is going to be the annihilator of the original function. In other words, what I mean is this. You have x. To find the annihilator of this is the power here is 1. So we said the annihilator is just going to be d to the power, just increase the highest degree, that which is 1, by 1. So that will be d squared. So that's the annihilator for x. Then we go to the next one. We don't really need the coefficient here, since we know if we can find the annihilator here, which goes to 0, anything multiplied by 0 is still 0. So we have x e to the power 6x. Now to tell you how to find the annihilator of this, I'm going to show you a very quick expression here. Now you recall that when you're trying to solve or trying to find the general solution of a homogeneous differential equation, there are three forms of the general solution. So the first form is this. So you have if you have distinct roots, you have your solution to be y equals c1 e to the power m1x plus c2 e to the power m2x. Now the next case is if you have equal roots and it is second order, and the differential equation is second order, you're going to have c1 e to the power m1x plus x c2 e to the power m1x. So but then the last case is if you have maybe your solution was the solution of the auxiliary equation is a complex root. You had complex root for the solution, that say alpha plus or minus I beta to be your solution. Then we said that the general solution there is going to be e to the power alpha x into c1 cosine of beta x plus c2 sine of beta x. Now these are the three forms of the general solution of a homogeneous differential equation. Now in this case, before we begin to do anything here, many a times the functions you're given could be written as one of the forms of the general solutions of a homogeneous differential equation. Now the only thing you need to do is which category does it fall in. So we have category A, category B, and category C. Now for category A is just multiples, constant multiples of e to the power m1 and m2x. But this is not just a constant multiple. Instead, it's like a variable multiple here. So you have x e to the power 6x. So you'd observe that it falls in this category here. It falls in this category. So I'm going to write this in this format here. So you're writing that in that format. What we have is, so it's like you're having, as if we're given y equals, say, c1 e to the power. So my m1 is 6x plus x c2 e to the power 6x. But how can it be equal to this? It can be equal when c1 equals 0 and c2 equals 1. So that is when C1 equals 0 and C2 equals 1. So when that is that, then we observe that we'll find this. So that means x e to the power 6x is a particular case of this general solution, So that implies that, because our aim is one friend, so it implies that the auxiliary equation from which this is formed is going to be m minus 6. Then since the power here is 1, the multiplicity is going to be 2 equals 0. Now if you can find the auxiliary equation, our aim is to find the annihilator. The annihilator is just the replacement of m to d, and then the remaining ones still stay the way they are. That's going to be d minus 6 squared. So this is going to be your annihilator for x e to the power 6x. But then we are told to find not just for this, but the summation of the two of them. So the summation of the two of them, the annihilator, is just going to be the product of the first one and the second one, and that's just going to be d squared times d minus 6 squared. So this annihilates this whole function. In other words, what that means is when you use this operator, when it acts on x plus 3x e to the power 6x, you must get 0. That's what it means. So now for the second part, which is c, 1 plus sine x. So you have c, which is 1 plus sine of x. Again, you observe that you have two different entities here. The first one is 1, and the next one is sine of x. So I'm going to find each of them separately and then multiply their operators. So the first one is 1. So the operator here is d, while the next one is sine of x. Now sine of x, to find the annihilator of that, I need to first find the auxiliary equation. Like we did here, we found the auxiliary equation. Now to find the auxiliary equation, I need to rewrite this as the general solution of a homogeneous differential equation. So which category does it fall in? So in all the three categories, we observe that this is the only one that has the sine property, has the sine trigonometric function sine x. So rewriting that, so let me rewrite that as, so it's going to be y equals e to the power, so since there's no e here, it's going to be e to the power 0x into, say, c1 cosine of, so this is 1, so this is going to be 1, so there's 1 here, that's sine 1x is still sine x anyway. I'm just trying to do that just for clarity's sake. So cosine of x plus c2 sine of x. But then we know that this goes to 1, so it doesn't really have any effect here. But then how can we get sine x from here? You can get sine x when c1, because c1 is an arbitrary constant, so you could take on any value. So when c1 equals 0, this whole thing goes to 0, and then when c2 equals 1, we have sine x. So we are still on track. So but then we recall that if you have this as a general solution, it implies that it must be gotten from the solution of an auxiliary equation of this format here. So that is to say, the auxiliary equation which we intend to find, the solution is going to be m equals alpha. This is my alpha here. My alpha is 0 plus or minus I times my beta. My beta is 1. This is my beta here. So our beta here is 1. So 1 times I is that. So in other words, we have m equals, that is, we have m equals plus or minus I. But then you have two values here. So that tells you have two values. So you have m1 equals plus I, and then you have m2 equals minus I. So we write this out. So if I bring this one here, you have m minus I equals 0. And if I bring this one to the other side, you have m plus I equals 0. Now if this equals 0 and this equals 0, it implies that when you multiply the two of them together, you should have 0. So that is to say, so this implies that m minus I times m plus I should give you 0. So when you expand this all together, you're going to have m squared plus 1 equals 0. Now this is the auxiliary equation which we intend to find. Now as far as you can find the auxiliary equation, the next thing you're going to do is convert or replace all the m's by d, which is like a layman's way of saying the whole thing. Anyway, you see m, you replace it with d. So I'm going to replace my m here with d. So this is d squared plus 1. Now this is the annihilator of sine of x. And then we observe that for 1, the annihilator is d. So therefore, the annihilator of 1 plus sine of x is going to be the product of the two of them. That's going to be d times d squared plus 1. That's going to be the annihilator of that function. And then the next one is 8x minus sine x plus 10 cosine of 5x. That's the next one we're looking at now. So that is part D.